So, like I told you at the very beginning of the term, this whole semester is all about factoring. Okay, so those of you that are working on something else right now, thank you. All right. So today we're going to be using our factoring techniques that we have already learned, whether we are x factoring or whether we're using sum and difference of cubes. And so we're going to use those things as we go through what are called rational functions. So if you look at example number 1, it's just a polynomial over a polynomial, so two binomials. So if you follow these steps 1, 2, and 3, you're going to do just fine if you do this every time. Remember we talked about you can't cancel above each other if they're not exactly the same. Remember we talked about that? So we're going to come across some examples where that might be troublesome, but I'm not going to let you be steered in the wrong direction. So let's talk about example 1. The first thing it tells us to do is to factor the numerator and the denominator completely. So if I look at number 1, how can I factor that numerator? What can we factor 9x plus 3? What can be pulled out of 9x plus 3? A 3. Okay, so let's pull out a 3 from the numerator. And that leaves me with what? What happens when I pull a 3 out of the numerator?
3x plus 1.
All right. What about the denominator? What can we pull out of the denominator? What can come out of 12x and 4?
4.
A 4. Okay. So if I pull a 4 out, what does that leave me with?
3x plus 1.
Interesting. Okay, so we've done step 1. Step 2 says to cancel like factors from the numerator and the denominator. Now, do you agree that the 3x plus 1 is exactly the same on the top and the bottom, right? It's not just a 3x and then a 3x plus 1, but they are completely and exactly the same. So if they are exactly the same, then I can cancel them. And now, we've done step number 2. So what is step number 3? Write your final answer. What's the only thing we have left here? 3 over 4. So that becomes my final answer. So this rational expression reduces or simplifies to just 3 over 4. Questions about that? All about that factoring. Okay, number 2, x squared minus 9. So again, we're going to factor the numerator and factor the denominator. What does x squared minus 9 factor to? Oh. We missed this on our test.
You make two parentheses with an x in each one.
Okay.
And be positive 3 in one x and negative 3 in the other.
Okay, because what Emily just described is the perfect squares, right? X squared is a perfect square and 9 is a perfect square, and it's subtraction. So you can put an x in each of them, a 3 in each of them, and then what do we remember out the signs? Plus minus, right? One's plus, one's minus. Okay, what about the denominator?
5 can go out of each one.
Okay, we can pull out a 5 from each side, or from each term, I mean. So if I pull out a 5, Tracy, what does that leave me with? So if we think about dividing out a 5 here and dividing out a 5, it cancels, and so I just have an x. What's 15 divided by 5? 3. And it's a plus 3. It's not squared, so I can't do plus and minus, but just an x plus 3. Okay, Emily Hagee, what do they have in common? An x plus 3 and an x plus 3. So I can cancel those out. Amanda, what am I left with in the numerator? X minus 3. Colt, what's in the denominator? 5. This is your finished answer. Now, you can put parentheses around the x minus 3, or you don't have to. It's not going to change the answer. Questions about 1 or 2? All about that factoring. Okay, let's look at example 3. Okay, does it matter now that I have a trinomial? Does that really matter? How do we factor a trinomial? 3 terms. What? Good, Chelsea. We're going to x factor, split the middle, right? So I'm going to look at the numerator. What two numbers multiply to get 5 but add to get 6? That's what I'm asking myself. What two numbers multiply to get 5 and add to get 6? You said what?
Positive 5 and positive 1.
Positive 5 and positive 1. Oh, you know, why can't you see this on yours? Okay. So positive 5 and positive 1. So now, some of you are splitting the middle, but remember the shortcut. If the number in front of x is 1, then I can just write x plus 1 and x plus 5. Splitting the middle will work here, but remember, if the number in front of the x is just 1, we can take the shortcut. Can we take the shortcut in the denominator? What is the number in front of x? 1. So can we take the shortcut in the denominator? Yes, we can. Okay, so now I'm going to ask myself, okay, what two numbers multiply to get a negative 2 and add to get a negative 1? Well, our only options are 1 and 2, right? Which one do we want to be negative, Chelsea?
2.
The 2. Excellent. So I have an x minus 2 and x plus 1. What's going to cancel, Patrick?
X plus 1.
Excellent. X plus 1 and x plus 1. What does that leave me with, Cynthia, in the numerator?
X plus 5.
What's in my denominator, Elena?
X plus 2.
X minus 2. Can we cancel out the x's at this point? Can we cancel out those x's? Why not? They're attached. Remember we talked about that. These two are attached together, and these are attached together. So you cannot cancel out your x's. Cynthia. This would be your final answer here. Okay? Now, on example 4, it says, whatever that says at the top, you can kind of forget. I used these notes when I subbed and students watched a different video. Okay? So let's look at this numerator. First, I know it's a trinomial, so I'm going to have to x factor and split the middle. But is there anything I can divide out of the numerator first before I x factor? A 3. Okay, so let's do that. Let's divide out a 3 from the numerator. And 18 divided by 3 is 6. Okay? Is there anything we can divide out of the denominator before we split the middle or anything? No. Okay. So it's up to you how you want to organize your paper. I'm going to just, from this point right here, I'm going to underneath it write my negative 6 and my 1, because now I need to x factor. So I'm x factoring what's in the parentheses. I'm forgetting about the 3 for a minute. So I need to figure out what two numbers multiply to get negative 6 but add to get 1. What'd you say, Tish? Perfect. Negative 2 and 3. And remember, our x value is 1 right here, so I can just take the shortcut. I have an x minus 2, x plus 3, and I brought the 3 down that I had pulled out. I'm going to divide this by that denominator, right? But before I can do the denominator, I'm going to have to, I have 2x squared, I'm going to write it over here, plus 5x minus 3. What two numbers multiply to get negative 6 and add to get a 5? Negative 3 and negative 2, I would agree that they make a positive 6. But don't we want a negative 6?
6 and negative 1.
I would say 6 and negative 1, right? So when I add those together, I get a positive 5. Now, can we just take the shortcut and put x plus 6 and x minus 1?
No.
No. Why can we not just take the shortcut here?
Because it's 2x squared and 5x.
Excellent, because there is a 2 right here. So instead, remember, this is where we're going to split the middle. I want you to do this. You shouldn't have to watch me. You should be able to do it on your own paper. You should be able to split the middle as masters now. So I have x plus 3 and 2x minus 1. Is anyone else working towards that? Good. Questions on that before we move forward? So that becomes my denominator. So underneath this 3 times x minus 2 and x plus 3, I'm going to put what I factored the denominator to be. X plus 3 times 2x minus 1. Those of you whose organization is not your strength, or your handwriting is not your strength, then you need to be very careful as you're doing this to keep yourself organized, okay? Anybody see anything that I can cancel here? I hear one person. X plus 3. Okay, so I'm going to knock out that x plus 3. And I'm left with 3 times x minus 2. And in the denominator, I'm left with 2x minus 1. Questions there? Factoring, 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 factoring. Did I mention factoring? Okay. All right, let's look at a couple more examples. I would like you to try number 5 and number 6 and then pause. I'm going to give you a few minutes and then I'll put them on the board. Okay? Try number 5 and number 6 on your own and see what you can do. Follow the rules in the box on the other side and you should be just fine. So first you are factoring the numerator, factoring the denominator, and then you are canceling. Not breaking it apart like this, but factoring. What do these two have in common?
5.
Pull that out. You forgot something. The top is not factored. Correct. Number 6. Yeah. I like what I'm seeing on number 5. You guys are doing great. On number 5, the only thing I'm left with is a minus 2. And again, you can put that in parentheses if you want to, or you don't have to. Okay, let's work on number 6. Pulling a 2y out of the numerator. The denominator is a difference of squares, right? Perfect squares, so that becomes y plus 4, y minus 4. And then we see we can reduce y plus 4 and y plus 4, or cancel them. So on number 6, I'm left with 2y over y minus 4. Raise your hand if this is what you have, please. Okay. Does anyone have any questions as to how I got this answer? All right, number 7. The numerator on number 7 looks like what we have been doing, right? X squared minus 6x plus 8. Okay, so we can x factor that, so let's go ahead and do that. What two numbers multiply to get 8? Add to get a negative 6. What factors are we looking for, Amanda?
Negative 2 and negative 4.
Negative 2, negative 4. Anybody agree?
Yep.
I do. Good. Now, can we take the shortcut and just set up our parentheses here?
Yeah.
Yeah, we can, right? Because there's just a 1 right here in front of that x. So in the numerator, I should have x minus 2 and x minus 6. That's what my numerator becomes. And then I still have this x cubed minus 8 underneath. Does anybody remember what we do with the denominator?
It's supposed to be a 4.
Oh, instead of 6? Sorry, thank you. What do we do with the denominator there?
Cube root logarithm.
Right. Do you guys remember our perfect cube formulas from lesson 3.4? I know that's forever ago. But lesson 3.4 has those perfect cube formulas. Do you guys remember that? And so we do, I'll write the formula down here. We do a minus b times a squared plus ab plus b squared. So how do I get my a and b value? Do you guys remember that? Whew, long time ago. What? Cube root it, right? What's the cube root of x cubed? X. I should hear 16 voices. What is the cube root of 8? 2. So there's my a and my b. X is my a value, 2 is my b value. And now I just follow the formula. You guys remember doing this? Please say yes. Okay. All right, so we're going to do a squared. So my a value squared is going to be x squared, which is just x squared. The formula says to add. So remember, I always follow the signs of the formula. Your a value times your b value. So 2 times x is 2x. And then your b value, which was 2 squared, is 4. So let's remember what we have in our numerator. We have x minus 2 and x minus 4. And then in my denominator, I have x minus 2, x squared plus 2x plus 4. Kyle, what are we going to cancel out here? Excellent. So the only thing I have left, x minus 4 over x squared plus 2x plus 4. So all we are doing is factoring every single time. Factor, factor, factor. Hey, factor some more. And then you can cancel. Okay? You need to be on the lookout for difference of squares, like on number 6, where that y squared minus 16, you need to be on the lookout of that. And you need to be on the lookout for perfect cubes. Okay? Because they will appear in your homework. All right, so this is just basic simplifying. So now if I wanted to multiply or divide, before we get too excited about this, I want to remind you about a basic problem. When you were back in like 6th grade, maybe 5th grade, if you had a problem like this, 3 over 4 times 2 over 6. Do you guys remember doing this? 3 over 4 times 2 over 6. And you could reduce and reduce, right? You could cross reduce. That would be a 1, and that would give you 2. Do you guys remember doing that? We're going to do the same thing, except we're going to have polynomials that we're going to reduce with. Okay? What would have happened if this was a division problem? Do you guys remember what you do if it's a division problem?
Flip it and do the same.
Thank you, Kyle. You're going to flip it to be a multiplication problem, and then you flip the second fraction. That's how you do a division problem. So on number 8, we see that it's a division problem. So the first thing that we're going to do is rewrite this. So I have 8 minus k over k squared minus 64. I'm going to change it to multiplication, and I'm going to flip the second fraction so that it's k plus 8 over k minus 8. You may want to make yourself a note to change division to multiplication and flip the second fraction. Okay, so step number 1 in our gray box above says, if it's division, rewrite the problem in multiplication. We just did that. Step number 2 says to factor completely all the numerators and denominators. So if I look at this problem that I've now created, is there anything that can be factored?
The k squared with 64.
K squared minus 64 changes to what?
K minus 8.
This changes to k minus 8, k plus 8. Now, if I look diagonally this way, they both have a k plus 8, right? And remember this example that we talked about up here in the left corner? You can cross cancel, okay? So what do you think we can cancel down there? I can cancel out a k plus 8 and a k plus 8. Now I'd like us to rewrite what we have. I have 8 minus k over k minus 8. What's in the numerator over there? Because I canceled out that k plus 8, but I still have something left there. What is it? Good, Kyle. 1. Is that what you were doing? Okay. And I have this k minus 8. Now, I cannot cancel these two that are beside each other. That's not how cross-canceling works. You don't reduce it if they are on the same level. But can you rewrite 8 minus k as something else?
Yeah.
What? All right, if you write 8 minus k as k minus 8, is this the same thing?
I don't think so. I would say no.
No.
Okay, look, the 8 is positive here, and what's the 8 down here? Negative. Is that the same thing? No, but what is the same thing?
Negative 8 plus k.
is if I take a k minus 8 and I put a negative 1 in front of it.
Well,
Because if I take a negative 1, if I take the negative 1 here, okay, so we're going to rewrite this one on the next line so that we don't confuse ourselves. I'm going to rewrite this as k minus 8. You don't have to do very many of these like this in your homework. And this is not something that I would have expected you to come up with on your own, okay? Let's think through this. What happens when I distribute a negative 1 here? That k becomes what? Negative. And isn't the k up here negative? And then what happens when I distribute a negative 1 to a positive 8? It comes out to be positive, which is what I had up here. All right? So this is the same thing as what I had up there. I just put a negative 1. I factored out a negative 1. Now I have a k minus 8 that I can cancel. Could you have canceled it like this? Could you have canceled top and bottom instead of diagonally? Can you reduce 2 over 4 like this? Top and bottom? It's not different. It's the same. So you can cancel, and we will have this experience. You can cancel diagonally across. Look at the board as I'm doing this. You can cancel diagonally across, or you can cancel on top of each other. But you can't do both, right? Because there's only one k minus 8 in the numerator. So that leaves me with, I have a negative 1. And then what else do I have in the denominator still? K minus 8. 1 over k minus 8 is not the same thing as negative 1 over k minus 8. Any questions on this one? This one was kind of tricky to start out with. Let's look at number 9. It is not as tricky. It is a division problem, so what do I need to do first? Rewrite it. And actually rewrite it. And I want you to rewrite it, not just put your arrows. Okay, I want you to actually rewrite it. So again, step number 1 is to make it division, and we did that. Well, I'm sorry, make it multiplication. Step number 2 is to factor completely. Does the first fraction need anything to be factored on it? That k plus 1 and that k minus 3, is there anything to factor there? No. So we'll leave that alone. But we can factor the second fraction, that k squared minus 4k plus 3. How do we factor that one? Okay, what are you doing there? You're x factoring, right? Is that what you did there? The top one. You said k minus 1 and what? Oh, you factored the bottom one. Okay. So I have k plus 1 over k minus 3. Chelsea went ahead and factored the second denominator. You said it was what? K plus 1 and... All right. So now we need to factor this one over here. What two numbers multiply to get 3 and add to get a negative 4?
Negative 3 and 1. Negative 1 and negative 3 and negative 1.
There you go. They're both negative. Negative 1 and negative 3. Can we take the shortcut here? So I have k minus 1, k minus 3. All right, what's something I can cancel out, Crystal? Either on top of each other or diagonally. What can you cancel?
You can cancel, x by k minus 1.
The k minus 1 and the k minus 1. Okay. Emily Harris, what's something else you can cancel?
K minus 3 on both sides.
K minus 3 and k minus 3. Austin, what's something else you can cancel?
K plus 1 and K plus 1.
K plus 1 and k plus 1. Well, shoot. What are we left with?
0.
We are left with
1.
1. Anything divided by itself is what number?
1.
Not 0.
Come on, people.
You will never get 0 as an answer. Okay? So we get our answer to be just 1. Yes, all of that work for just 1. It's nice when it cancels out like that. Questions on number 9? All right, we're almost there. Factoring, factoring, factoring.
A little bit of more factor.
Some more factoring. I told you guys. You thought I was kidding. Now, on number 10, it's already multiplication. Do you see that? It's already multiplication. So we don't need to flip anything. We just need to be factoring. So I would like you to save. I don't care how you do your factoring, but I want you to save this space right here for your simplified factoring. All right, so what happens when you factor each of those? Save this space right here. Maybe put a box around it so you don't crowd it. And then all the way around the paper, I want you to do, you have 4 x factors you have to do here. 3 of them can be the shortcut. But that first one, the 3x squared plus 7x, that one you're going to have to actually split the middle. Okay? So I'm going to give you a few minutes. X factor, you know how to do it. Keep yourself organized. Bless you. If you need to check, Okay, keep going. Okay, once you think you have the blue box and you've checked your blue box with mine, then I want you to go ahead and start canceling some things out. Keep going. Here, it's fine. You what? 1 and 2. Your brain's working overtime. Some of you maybe could use a different piece of paper, which would be a good idea. Did you cancel some things?
Yeah.
You're missing a sign. This right here should be an x minus 4. Okay, I'm going to go ahead. If you're still working on it, that's fine. And cancel out an x plus 1 and an x plus 1. I can cancel out an x minus 4 and an x minus 4. I can cancel out an x plus 2 on the top. I have 2x. Everyone look up here for just a minute, even if you're not finished. I have an x plus 2 at the top right here. And I have 2 of them on the bottom. But can I cancel out 2 on the bottom, or can I only cancel out one group? Only one group, 1 for 1 here. So I'm going to knock those groups out. So the only thing that I have left on the top is a 3x plus 1. And on the bottom I have an x plus 2. It's so important to stay organized when you're doing this. Okay? Those of you who have questions on 10, I'm going to come around and help you with them. I want you to start on number 11, though. If you got 10 right, go ahead and start on number 11. Did you actually get that, or no? Did you just write down what I had? I
You were
actually
going
had
too
that.
fast for me, so I was just like,
Okay.
I can't.
Okay, on number 11, make sure that, again, you're keeping yourself organized. Okay, what's something that I can cancel out, Josh? On number 11, what's something I can cancel out?
Plus 3.
Okay, d plus 3 with d plus 3. Austin, what's something else you can cancel out?
D plus 2.
D plus 2 with d plus 2. Chelsea, is there anything else I can cancel out up here? No. Does anybody else agree with that? Okay, so because there's nothing else to cancel out, you're going to collect the numerator. So what do we have in the numerator left? I have a 2, and I have what?
D plus 1.
D plus 1. So when you multiply a fraction, you multiply straight across. So it's going to be 2 times d plus 1, and we are not going to distribute. We are going to leave it separate. Yeah. Because if you distribute it, then it looks like you can still pull a 2 out, and then it would not be simplified. And in the denominator, if there was something left on either fraction, we would just write them beside each other. But there's only a d minus 1 left, so we just are going to put d minus 1. Finished. Does anyone have any questions about this whole process? But whether it's multiplication or division, it's the same thing. You just have to make sure you change your division to multiplication problem first. Okay?